Okay, right. So we had 4 tables, table my contacts, the current table. So my contacts is just the contact. So I'm basically a job hunter and I have all my contacts saved in this table, right? Their name, their email, the zip. I think there were more, their birth date, the gender, and so on. So I have all this information in a table. And then I have 2 more tables. Table current is telling me who is working right now, and table job desired is telling me who is looking for jobs, though they may or may not have previous jobs. The job listings table is not linked to any of them. It's not related in terms of foreign key relationship, but it tells me what jobs are available in the market. And definitely, if somebody is desiring a job, I can look it up. I can say, oh, is it in the job listings by help of the title? In this example, the common fields that are related to each other have the same name, but there is no rule. And in my next example, I'll kind of go the other way. I'll do it without rules. I'll say, oh, they don't need to have the same name. So it's up to you. If you want to keep same names when you create databases, sure. If it confuses you and you say, oh, I would like to give them different names, the ERD helps you. So I prefer to use this ERD because it tells me that this contact ID is related to this contact ID. Even if their names were different, the line tells me which field is related to which field. And similarly, it says my contact ID in the first table is related to the job desired table, again through the same field, my contact ID. Now keep in mind that for this ERD, unfortunately, it is a wrong ERD because it's showing me a one-to-many relationship in my contacts and job current and job desired, and that's not the case. Why it's not the case? Because the contact ID in both the other tables are primary keys. So how can you repeat a primary key in a table? I mean, you cannot have records with the same primary key. And this is saying one contact ID can do more than one jobs, or one contact ID can have more than one job desired, which is true in the real sense, but it's not true for my tables. So I'm kind of confused that reading the structure of my table, seeing that it is a primary key, that the values will not be repeated. How is it saying that there is a one-to-many relationship? So this is just to caution you that if you're going to use this program to draw your ERDs, double check that they are done correctly, right? I am restricting to that one contact can only have one job currently and can only desire one job because it's a primary key in my other table. This contact ID is a primary key. I can take care of it. Instead, I can create another field called ID as the primary key, and the foreign key remains the same. The primary key becomes different. And we'll do that in another example. So the diagram that MySQL Workbench is drawing is not correct, just for your information. At least for this one, it is not correct. So when you draw it, and if you're going to use this software, be careful, double check that what it is telling you about relationships and everything is entirely correct. So today is the last day also, just so that you know, if you do not have a partner, please email me because I'm not going to accept individual assignments, right? So if you still don't have a partner, email me and I'll click you with somebody. I have been doing it over the past 3 days. I think I made 4 or 5 pairs. So people, I mean, maybe they just don't know who else is in their class, or they don't attend classes, or whatever it is, right? So I have 1 request still sitting, still pending, and I'm looking for a partner for that particular girl. So if you don't have a partner, email me today. After that, it's up to you. No individual assignments will be accepted. I won't. It's just too much work for me in the sense of I want to work, make you work together. Okay, so now that you've seen the ERD, which they call EER, Enhanced Entity Relationship, and I call ERD for Entity Relationship Diagram, kind of brings back memories of what it is. So when you give it to me, again, you have to tell me what this red color means, what the key symbol means, and so on and so forth. What does the blue symbol mean? What does the diamond symbol mean? So you should have a legend which tells me what's going on, right? Okay, let's come back to what we were doing, and we will learn a few new things today. And we'll stick to the old, of course, can't forget the old. It says, now give me the name and email of all contacts who currently do not have a job. So there is a table called job current, which tells me who has a job. But I want to know people who do not have a job. So the my contacts has all the contacts. Job current has who has jobs. So if I subtract the two, I'll get people who don't have a job. right? Logically, if you think of it. So I have a list of all my contacts. Then I have a list of people who have jobs. So if I remove these people who have jobs from my list of contacts, then what I'm left with is who doesn't have a job. So inner join won't work because I'm not trying to join on something that is common. I'm trying to join on something that is uncommon, right? So you are here and you are not here. So always when a question comes to you, think of saying, am I trying to look for something that is common between the two, or inner join will work too? Am I trying to look for something that is here in one table but not in the other table? You will always need an outer join, because an outer join helps you do a subtraction, kind of a minus, which is not available, except which is not available in MySQL. So now that's the first thing. I will need an outer join. Two, what will be my major table? Till now we've been talking in terms of efficiency and so on, and it still remains your program should be efficient. But now logically also think what should be your master table? All the names are in my contacts, and the information who doesn't have a job is coming from there, right? I just have to remove people who have jobs. So in this case, though my contacts is a bigger table, could be bigger than what I have, I still have to use that as my major table, because that's the table which has the information that needs to be extracted. I just want to remove people who have a job. So the master table in this case, though it's the bigger one, so it's not always the case. So the smaller is the master table. The master table is my major table. So when I write a join, I have to remember that master table is my contacts table. Whether you use a left join or a right join, that's not important, but that is your master table. And I'll show you the other one. If you take the other table to be the master table, actually it doesn't even work in this case, because logically those are people with jobs. What am I subtracting from it? Nothing. Those are people with jobs. On the other hand, from my whole list, I must subtract or remove these people. So this becomes my major table. So therefore, I haven't even asked for an inner join, because inner join will not work. There is no solution with inner join for this table. So what I'm going to do is I'm going to select, it says name and email. So we name and emails, we've been kind of working with names and emails. I'll just concatenate it, though it's not necessary that I do. If it doesn't say anything, I just say, oh, okay. So I'll just give the whole name. So concatenate your first name and last name, putting a blank in between, and it says email. And that's the field name from that master table. Okay. Now from. So my master table is table, and it was called the my contacts, right? Now this is my major table. So I'll do a left outer join because I've put it on the left hand side. I think somewhere I read that left was more efficient than right, though I don't understand a lot. Why would they say that? But I didn't read further, but it's something that I read somewhere. And then on the right hand side, the other table that I'm interested is in the table current. So logically, if I remove the current contacts who have jobs from my contacts, what am I left with? People who don't have jobs. And that's exactly what I'm doing, right? So again, whenever you do an outer join, and I highly recommend it, guys, especially when you're doing your assignment, first kind of do a join and then see, oh, it looks okay, and what should I remove? And how will you join them? Definitely, you can use using if you like, but what is common between job current and my contacts? The contact ID, right? So if, just to be lazy, I'll say using, and lazy means, oh, you know what? Using only shows it once. So I'll do the on. The difference between on and using is using will show you the contact ID field only once, and on will show it twice. Why am I looking at it twice? Because when I look at the table, I want to show you something in that my contact ID. So take your table, my contacts, give it a name maybe. So my contacts, you don't have to. Job current. What does it save you? Short names. MC dot contact ID is equal to AC dot contact ID. Let's only look at this first, because that's what I'm saying. So let me say everybody in the my contacts says hello to everybody in job current. Definitely some people won't have a partner. So let's see who doesn't have a partner. 7 and 10 don't have a partner. That means these are people without jobs. Right? So why did I do an on? When you do on, you will see the contact ID field listed twice. One for the first table, the second from the second table. When you do using, you only see it once. So you kind of, why, and I want to see my primary keys just so that I can see where it is null. Because when you do anything on a table, always the first notion should be, I'll use the primary key. So what do I want? I want record number 7 as my answer, and I want record number 10 as my answer. These are the people who don't have a job. So if I say where the contact ID is null, I'm picking up the people who don't have a job. So just add it. So once you see the table and you see, okay, now which records do I want to pick up? I want to pick up those records where, now add your condition. I want to pick up those records where the contact ID of JC, what was the second table? JC. The contact ID of JC is null. Those are the people who don't have a job. And it will work now because we've already seen the table. So whenever you do an outer join, go step by step. The first thing, just do a star so that you see all the fields of first table, you see all the fields of the second table. That's what I would recommend. That's how I learned it. And 99.9% cases, I don't go wrong. There's always a chance of going wrong, right? But if you see the tables, you see all the fields, you see, oh, this is what is happening with an outer join. And then now, oh, that's what I want. And now what do I want out of these? You look at the fields and say, oh, I want the field. I want those records where the contact ID of the second table, which is JC, is null. I could use any field. I could use title. I could use salary. I could use start date. But I stick to primary keys because primary keys are there for a reason, right? They are unique, so I can never go wrong with them. So you could have said contact ID is null, you could have said title is null, you could have said salary is null, you could have said start date is null. Again, it's whatever you like, but in databases, keep something in mind. Let me first try if I can use the primary key to update something, to delete something, to select something. Then if that's not what you want, or it doesn't work, or that's not the question, then you use some other key. So now I should have my result. I should see the result for those 7 and 10 only. There they are, 7 and 10, right? These are the people who don't have a job. And now I'm only interested in their name and their email, because I'm going to email them saying, oh, did you have any luck? Or, oh, I have this in the market. And there they are, their names and their emails. So do them step by step, and hopefully you will not go wrong, because you're seeing your solutions as you go. And again, when you do your assignment or when you do your exam, whatever it will be, write an answer, run it, see that it is correct, double check it, it's fine, and then go to the next question. Because if you try to write everything and then try to run, you'll never find where the error is occurring. It takes more time. This way, I write a query, I run it, I know it's fine. Till this point, I know that 441, everything is going fine, right? So that also saves you time, okay? Now, just to show it to you, that why did I not, and it's logically incorrect. It's logically incorrect because how am I looking for people who don't have a job in the other table? Like, how can I make that the master table? So I will say right here, and this will make job current the master table. So basically it is saying job current table, you pick up one record at a time and say hello to my contacts. Everybody will find a partner. Everybody who is in job current has a partner in my contacts. So I can't answer that question by making this job current as my current table. It won't work. You will see the answer. So I'm just going to run, again, I'm going to do this. I'm going to put a star here, comment out the rest of the line, and will not do anything null or anything. I'll just do this. I'm just trying to do an outer join using job current as my current table. And that's what is expected. Everybody in the job current has a partner. Definitely. So from where will I get the information of who doesn't have a job? So logically, it is incorrect to make JC, the job current, a master table. I cannot do it. So there is no question of efficiency or inefficiency here. It's just cannot be done in this solution. Look at the answer. The answer is telling me everybody who has a job. That's exactly what you said. Pick up from job current and say hello to my contacts. And that's what it did. It found a partner. Everybody will find a partner because all contact IDs are coming from my contacts. So this is not the correct answer at all. It's not even it's not even an option, right? That, oh, can I do it this way? Can I make the other table a major table? So please make a point. I leave it here, but this is not the right solution. This is not the correct solution. So again, which table is my major table is an important concept to understand in outer joins. One, for the reason, does it work or doesn't it work, which we've just seen. And two, for the reason of efficiency. So if I've said, please write efficient code in your assignment, then I'm basically making you think. In the exam, I won't bother to, because exams are always stressful, right? But in an assignment, which you have 2 weeks, 2 partners, you can think, oh, which will be more efficient? And how do you do it? All you do is you write your joins first, look at which has more records, and definitely one that is fetching more records will take more time. That is the less efficient one. Sometimes the time here will help in your lower window, and sometimes it won't help because it usually shows 0 seconds because it is less than 1 second. So it's not even showing you. Sometimes it does. But always say, if you're confused that which should be my major table, write it. Write both the joins, right and left, or make both the tables major. Then look at their output. The one that has more records definitely is taking more time to work. That means that is less efficient, right? So if I'm not mistaken, I think in your assignment, I said, please write efficient and non-redundant code. Non-redundant means code that is not required. You're joining a table and it's not even required to join it with it. So some people don't even think. Some students will say, oh, I'll join this, this, and this, whereas maybe the third table was not even required in the join. So in your assignments, please put your heads together and do it well. If you do it well, you will definitely get good marks in your final exam because it's a major part of your final exam. Keep that in mind, right? So don't take it lightly, guys. It's 20% and so is your final exam. So it's all kind of based on that. And of course, whatever you've done from the midterm, we've done select statements, which you've done functions, max, min, you've done group having, all that we've done. And all that kind of will go on also onto your final exam. And alter statements we still use if we have to. So that still remains. Okay, so do it well. And that's why I gave you 2 weeks for it. And I'm doing so many examples with you. Okay, so that's not a solution at all. So the only solution is the my contacts table is your major table. From that, you're trying to subtract or remove anybody who has a job and keep people who do not have a job. That's the condition. Keep people who do not have a job. And the answer is right. Okay. Now, can I answer the same query using a subquery? Sure. Why not? Let me select people, select the contact ID from the table job current. So this tells me these people have jobs. Right? These people have jobs. Now I want the name and the name and the email from the my contacts table. You don't have to give it a name if you're not using it. If there is no confusion in subquery, the inner query is independent of the outer query. So there's no confusion of names. But anyway, now from this table, I'm only interested in the names and email of those contacts where the contact ID not in this table. Make sense? So I pick up a person, I pick up somebody from the my contacts table. My first record is picked up. Is your contact ID not in the job current? No, you don't have a job. Is your contact ID in the current? Yes, you have a job. So that way you're saying you're not in that table. So you're basically doing a minus, right? You are kind of removing or looking for those records that are not in the contact ID. Please remember, Not in, not the relational operator. You can't use not equal. You can't use that. Same as in and equal. This is a list. Remember, this is a list. You could say, oh, because I have no idea how many people are working. It could be one, it could be two, or whatever. But this is a list. It's a list of contact IDs. So if you're trying to say contact ID is not equal to, you can only use not equal when you're comparing a value with a value. So you can't use it, right? So the same concept that you have, that I've talked about, that in and equal, always think, do I need an in or do I need an equal? Similarly, you will have to always think, do I not need a not in or do I need a not equal to operator? If this was a single value, then I could have said not equal relational operator. But I know that this is a list. It returns more than one, definitely. I mean, it could. I have no clue, but it could. And you can always find out how. Count the number of records in job current and it will tell you. So many people have jobs. So definitely it is a list. So in a list, I can only peek and say, are you there, or are you not there? I can't compare a value with a list of values. So you use the operator not in. And you must have the same answer. 7 and 10 are the two people. Renee and John are the two people who do not have a job. Right? Makes sense? So who has a job? Make a list. Go to your contacts and say, only pick up those contacts that do not exist in that particular list. Clear? Are we clear with subquery? Now, something that is a correlated subquery. What is a correlated subquery is entirely new. As the name suggests, it is a subquery, but it is related. Related means the inner subquery is related to the outer subquery. You'll say, why would I do that when I can do it without correlation? That's not the question. Why would I do that? What I want to teach you is what is a correlated subquery so that you get it. And I'll tell you how I kind of understand it. If that helps you to understand it, good. Because it is a little kind of not so clear as joins and outer joins. So what I'm going to do is I'm going to copy this for you and kind of look what I'm going to do. So I'm saying select the name and the email of those persons from the contacts where they do not exist. So the verb is not exists. You kind of know how to write subqueries. Correlated is kind of the same thing, but you just have to be a little careful. You use not exist and exist. So you're saying select all those names and emails from the my contacts table such that they do not exist in the join of this table. So this is not yet complete, okay? So they do not exist in the join of the table. I'm almost positive. Give me a minute, guys. That it can be done using a subquery. If not, then I must have made a note for myself, but I'm almost positive it can be done. Yep, it can be done. Okay, so where that does, so what I'm trying to do in the inner one is this. I'm going to make a join condition. So in the inner subquery, you're trying to do an inner join indirectly, where the jc.contact ID is equal to the MC dot, here I'll need names. So think of it. What is the inner 460 query doing? Kind of. It is making an inner join of the JC table with the MC table on contact ID. If you think of it, that's what it is doing. It's saying select contact ID. Oh, you'll have to qualify this one also because two tables are involved. Or maybe not. Anyway, so you're saying that I'm trying to look for those people or those contacts such that they do not exist in the join of the two tables. So it's going the other way. So you're saying join the two tables. What will join do? People who are common. And then you're picking up those contacts from my contacts that are not in this join. So they do not exist in that join. So why is it correlated? It is correlated because there is a condition in the inner query that is referring to the outer table. So this, therefore, it is called a correlated subquery. Why a subquery? Because it's a query within a query, but it is correlated. This condition, if you kind of just look at it, if you look at just this one, it's, I mean, though I haven't mentioned the second table is mentioned outside, but that statement at line number 460 is an inner join of job current and my contacts on the contact ID. It's an inner join, right? I didn't mention the table name again because it's already mentioned in my outer query. I used it, mc.contact ID. So it's an inner join. So what do you have? Everybody who has a job, their information, right? So here, instead of even writing J contact ID, you could put a star and it will still work because you're just joining, you're making an inner join. But using one field is better than selecting many fields. And now you're saying, I have that join. Now pick up those contacts from my contacts that do not exist in this join. So who are those people? People who don't have a job, right? So you will have to get your head around this because this is a new way of doing it. But if you think how I am thinking, maybe it will help. Again, you can make your own thinking process. But this is how I think it. The inner query 460, line 460 is creating an inner join of the MC and the JC table on contact ID. We've done that many times. So when you join the two tables, everybody who has a partner will be joined. And these are people who have jobs, right? Now I go back to my contacts table and I say only pick up those records that do not exist in this particular join. So those are people who do not have a job. So this should also work. So not exist and exists. We'll talk about exist in the next example. These are the two keywords when you use a correlated subquery. So run it and you must again have the same answer. And you will, if you logically think about it. You joined the two tables and then you said, my contacts, does your record exist in this table? Does your record exist in this join? If not, show it to me. So not exist says it does not exist in the join. Now of these three solutions, I've given you three solutions. Again, in an exam, I won't bother you necessarily with saying use this or use this, but you will be tested on exists and not exists, right? So anything you do in class, you will be tested. And of course, there is one in your assignment also. So please practice it. I'm not sure how you want to get your head around it, but this, I've told you my trick. The inner is a join. The subquery is a join. It is an inner join. So inner join means common, people who have a job. And then I'm saying pick up those from my contacts that don't exist in that join. So those are people who do not have a join, right? It took me a while to get my head around. I'm sure it will for you, but I've given you my trick, so maybe it will help you. Okay? So that's how it is done. So all three are working. And again, how will you learn it? By practice, right? It's all practice, nothing else. Okay, let's look at 7A now. It says find all the job titles that are desired and are in the job listings. So let's go back to the ERD. I am interested in the titles that are desired and are also in the job listings. So though there is no relationship between the two tables, I don't see a connecting line, but there is a title here and there is a title here. They may not be have called title, they could be different names, but it's the same data. So job desired says I want to be a computer programmer, and there is one in the job listings. Job desired says I want to be a chef, but there is nothing in the job listings, and so on and so forth. So people are desiring some jobs. My question now is I want to find out which titles are desired and are in the listings. So when you are thinking of they're here and here, inner join, right? They're here and here, inner join. You can write it as an outer join also, but the inner join is the most obvious one when you try to do a link. I want to say hello and you are here to just say hello to each other. So let's write it. And then I'll show you how you can do an outer join also, if I can. So let's write the join. Which two tables are we interested in? This table, the job desired, and the job listings, right? So these are the two tables we are interested in. That's your first thing. What tables am I interested in? So let's do a select. I'm just writing the names of the tables first. So the two tables are TBL, job current. You can write the word inner join, you can put commas. And the second table is TBL job listings. And I'm only interested in the title. Now there is a title in current also, and there is a title in listings also. So I'll have to qualify it. I'll go JC.title. And what is JC? I'll have to give them names then. And how are they joined? They're joined using title, because that's the common field and you're doing it on equality. So you can write using and it will work perfectly, or you can say on JC dot title is equal to JL dot title. And you know that you can do a using. You can always do using also. Don't forget anything. The more you practice, the better you will become. Believe me. So you're just joining the two tables. Are you here and you are here? Yes, this is the title which is desired and is also in the job listings. Okay. So this is the easiest way. This is the easiest answer that comes to mind because it's an inner join. Like it's a normal one. Of course, you can always do a natural join if you like. So I could pick up the same thing here. You can write the same thing as a natural join. Remember natural join? Same field on equality. The name of the field must be the same, which it is, title and title, and you are doing an equality. You can use a natural join also. Of course, you can do the using also. Right? All this is something that you've kind of learned before. Now, if I want, let's see who desires a job and it is also in the job listing. Let's see if it works. It should work, but let's see. So we definitely know that, oh, these are people are in the job listings. It's the opposite, isn't it? Something is not right. Because there were people that are desired and are in the job listings. This is giving the opposite. No, something is wrong. Okay, so let's look at it. Job current. Oh, so sorry, not the job current. Job desired. Using the wrong table. People who desire a job, their information is in job desired, not in job current. My mistake. Sorry about that. So when I see the answer, it doesn't look right because I know it because there were two people, there are 4 or 5 in the job desired table. Somebody was looking for a baker, a chef, a computer programmer, and so on. So I know the answers. And the problem was that I don't have the right table. There. Titles that are desired and are in the listings. So it should work now. Oh, error. Unknown column title. Oh, JC. Where is JC? There is no. In my select. Thank you. It's called JD now. There. So Baker was looking for a job. There was a person looking for computer programmer. There was another person looking for computer programmer. So if you want to leave it at this, sure. If you only want to see computer programmer once, that's fine too. This tells you 2 people are looking for computer programmer jobs. It gives you that idea, right? So 1 person is looking for a baker and 2 are looking for a computer programmer. If the question was I only want distinct ones, and I don't want to see repetition, though this tells you 2 people are looking for computer programmer, but if you want to, you can always, if only to be seen once, if unique values are required, what can you do? All you do is you pick that up and put distinct in front of it. And it will work. It will only show computer programmer once because you've put distinct in front of it. Just as a side, you can also do it this way. You can actually also use group by. What does group by do? Group by groups them together, right? So instead of using distinct, though it's not a usual practice, but just to make you aware of it, you can use group by instead of distinct. It does the same job because group by groups them. So if it groups them, then it's basically, will only show it once. Just so that you know, I've never done it, but it would be good to know. So I can remove distinct from here and I can do a group by here. And you, of course, will group by titles, right? Even this will do the same thing. So putting distinct will show the computer programmer only once. So if that's the question, that only show it once, sure, put distinct or use group by. Distinct is more common because it's more intuitive. I mean, you can look at it and say, oh, I'm trying to only show distinct values. The group by is not as intuitive, but it does the job. Why? Because you're grouping. So all bakers will be grouped, will only show it once. All computer programmers will be grouped, only show it once, and so on. So it depends on what you're doing. Are you trying to look for all information? 1 is looking for baker, 2 are looking for computer programmer, 3 are looking for sales manager. And I mean, you can have that information from here. If you're only interested in the title once, then you can use distinct and it will only occur once. So it depends on what you're trying to do. Okay, so use the distinct word if you want to see unique values. You don't want computer programmer to come twice. But again, it depends on the question. Or use group by. Group by does the same job as distinct. Why? Because you've just grouped them. So group them means only one at a time. So that works too. Okay, so I've written both. The question was not clear. It just said find all job titles. It didn't say distinct or it didn't say unique or anything. And of course, you'll say, what does she want then? But I'll be more careful when I do an exam or an assignment, right? Here I'm showing you both. Okay, makes sense? So I did an inner join and I showed you how to kind of do it. Now I can do an outer join if I like, and I'll show it to you. I can do an outer join. So this is the most instinct thing that comes to you. Oh, you are here and you are here. So let's join hands. But I can also do this. I can say, okay, I'm interested in those titles that are in my table, in my job desired table, and also in here. So if you look at the other way, you're saying the titles that are here and not here, kind of same kind of stuff. So it's not the most intuitive answer. Whenever there is equality, inner join makes more sense. But since we've done outer joins, I'll also show you how you can do this using an outer join. Just so that you see it. By now you have kind of done it many times. So let's select the same again. Distinct and not distinct. I'm not making, you can do it either way. So I'm going to take JD. Why don't I just copy it? Oh, here also I would have had an error, right? This was also JD. Didn't run it after that. I'll just copy it from here. Put it here. And then what I want to do is from the job desired, I'll do a left outer join. I'll show you one step at a time, okay? I'll always show you one step at a time. You can, just for the heck of it, you can do using, just because, so that you don't forget it. Because I've already said you can say using. So let's do this one step at a time. Then we'll see what we want. What have I done? I've said, okay, job desired table is my major table. it's going to say hello to everybody in job listings. Now, why did I take that as my major table? Because it was shorter. Job listings was a bigger table, right? So that was a smaller table. So I said, okay, pick up a record, find a partner. Oh, it's available. Pick up, find a partner. I couldn't find it, not available, right? So now look at this. What will I have? Every record in job desired is saying hello to the record in the job listings. Some say hello and they get a partner. Some say hello and do not get a partner. So I want to keep these people who have a partner. The first three have a partner. That means, oh, they're available. So what should I pick up? Where the job ID here is not null. Pick up those records where the job ID is not null. These are those contacts that are available. So pick up. Where? Once you have the table in front of your eyes, now you know which ones to pick up. And why am I picking up job ID? Because job ID is again the primary key. And it makes sense to do that. Where job ID is not null. So these are people who are looking for a job and they also are in the job listings. And these jobs are also in the job listings. Make sense? So I can do it using outer join, though the inner join seems to be most obvious because we are saying you are here and you are here. Oh, you're here and here, match up. But outer join says you are here and you are here or not here, I'll find that out. So I started with job desired as my major table because it was smaller. So I'm assuming it is more efficient. And how will you see? This is giving you 5 records. Try the opposite. Do the right outer join and see what will happen. In the right outer join, it will be a bigger table. Bigger table means more work, right? So always, you can always see which is efficient, which is more efficient by just changing the right outer join and see how many tables do you have? How many records do you have? Okay, so let's try to write this using a right outer join. I won't put the condition yet. Okay, I'll just do this. See how many records we have. Definitely I have more. Notice I have more records. So I can do it using right outer join, but it is less efficient because more record means it took more time to select. So it is less efficient. Now from here, how will which records do I want to pick up? Which people have jobs? These, the first 3 have jobs because they found partners. So I'll say where contact ID is not null. So I can use this field where contact ID is not null, right? So you can use it using the right inner join, which is less efficient, but the condition will then be where contact ID is not null and the contact ID of the second table. So where are you, right outer join? Here you are, right outer join, and job ID won't work here because job ID, everything has job ID, where the contact ID is not null. See, so you have to kind of look at solutions may be possible, and they are. So I did a right outer join. I made this as my since more records are selected. You can always double check. And I just did that. I saw, oh, how many do I have? I have definitely more than what I had in the other table. 5 people saying hello is different from 15 people saying hello, right? Definitely 15 people saying hello will take more time. So every job listing was picked up and it tried to find a partner in the other table. If it finds more than one partner, it says hello to both partners. So computer programmer 13 said hello to 7 and it also said hello to 8. It found 2 partners. It says hello to every partner it finds. So because this is a bigger table, I can conclude that it is taking more time, right? I'm not sure because the times don't help always. They always kind of come to 0 and they're not very helpful. But logically, thinking as a programmer, I'm saying because it is retrieving more records, it is less efficient, right? And notice here I have to say my contact ID is not null. So I did a right outer join. I changed the left to right so that I don't have to change the placings of my table. So now you remove now let's see if it works. I should only have those 3 people. I only have those 3 people. And then I'm only interested in the title. So I'm only interested in the title. And of course, both these outer joins and inner joins, you can put unique in front of it and they will give you unique results. They will give you distinct results. So if I just copy and just, so both will work in the other one also. If unique is required, all you do is just put unique in front of it, which is distinct. Sorry, not unique. The word is distinct. Or group by, whatever you like. Leave a space and use distinct. And you have the same option. You can again do a group by if you like. So distinct is same as group by, kind of, if you think about it. Because grouping also makes a group per whatever you are doing, per title in our case. So it is distinct, right? So all of these will work and the answer will definitely be the same. So all of this should show you that computer programmer and baker are looking for jobs and they are in the listing. So this is distinct, 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 4, and then 4 without the distincts. Right? So one gives you an idea of how many people are looking for a computer programmer. The other one just gives you an idea of somebody is looking, there is a listing. You know what I mean? So it depends on what your query is. What is your client asking for? Let's now do it using a subquery. So we are interested in those titles that are here and here. Okay, so let's find out what is here first. So select title from table job listings. These are all the titles in job listings. Right? Now, what do I want? I want to select the title from the table job desired where the title is in the other table. Again, not equal to, in. You can't use equal here. Why? Because the title from job listings is a list. It's a list. This is a collection. This is more than one values. I mean, we know there is, but definitely more than one can exist in title. And therefore, you cannot use equal to. Right? And you'll get an error. Because you can't compare a value with a list of values. One value with a list of values. And even if you don't peek in the data, you can always say select count and it will tell you, oh, there are how many records are in the other table. And this should also work. If I've used the right table, job desired. Last time I did the wrong table. Here, computer programmer, baker. Again, if you want distinct in front of it, you can just write the word distinct and it will give you distinct titles. Make sense? Now let's do the correlated subquery and think about it. Now, how will I think about it? I'll do the same thing. I'm saying, oh, I'm joining the JD, the job desired, and the listing table. And I want to pick up those records that are present in the job desired. So if you kind of pick up this from here, and that's how you can make sense of it. It's like a query. It's like a subquery for sure, but it's correlated. So now you're saying select the title from the job desired table where it exists in the join of, if you know subquery, correlated subquery kind of will be easier to write. Where it exists here. So I'm doing an inner join. And since I'll have to do a JL, and I'll have to do a JL title is equal to, we'll call it JD in a minute. Okay, now again think of it. Pick up the title from the desired table such that that title exists in the join of desired and listings. So definitely it's not the efficient solution in this example. It's the least efficient. Why? You're doing an inner join and that could have given you the answer anyway. But after doing the inner join, you're again going back to the desired table and saying, are you in there? Are you in there? So you're doubling up the work, right? So this is the least efficient. There is no doubt about it. But my aim was to show you the exists and not exists keywords today and introduce you to correlated subquery, right? So a correlated subquery basically means you cannot run the inner subquery independently. You cannot see it's saying JL, which is right there, but JD is not even, it doesn't even know what JD is. You can only run this query together, like as one piece. And that is the answer. Whereas in this case, in a subquery, which is not correlated, you can run this distinctly, like just as a standalone statement, right? So therefore, it is called a correlated subquery. So again, exists and not exists are verbs or keywords that are saying, do you exist in that bin? And what is that bin? That bin is the inner subquery which has made a join with the outer table. Okay? Or do you not exist in that bin? So therefore, the verbs exist and not exist. So pick up the record. Do you exist in that bin? Pick up the record. Do you not exist in that bin? Depends upon the question you are doing. The first one was not in, and this one is not exist, and this one is exist. And I have the answer. If you run it together, not together, I mean if you run it, there's your answer. And again, if you want distinct, just put distinct in front of it, and it will work. Okay. Last in this, and then I'll give you a break. It says find all job titles that are desired by more than one. We just found out there was a baker, there was a computer programmer, there was a computer programmer. So there is an answer. Find all those job titles that are desired by more than one and are in job listing. So more than one people or person, you can say, more than one contacts, you can say. You've done half the answer. You know which jobs are desired and are in the listing. What should you now impose on it? What do you have to do further on it? I know what are desired and what's in the listing. I already have that information. What should you impose on it now? What do you have to look for? So when it said baker, computer programmer, by looking at it, you said, oh, computer programmer has more than one, findings. So that means more than one contacts are looking for computer programmer. But I just don't want, if it is a long list, I don't want to count myself. If I could say you count for me. So group them up. And then if the count is greater than one, that means more than one contacts are looking for it. Make sense? So first find what is available, what is desired, what is in the listings, and then group it up. Group them up. Now for each group, pick up only those groups where the count is greater than 1. So we already have an answer for how to look up. So let's look it up using anything. All of these will work. I'll just take the first one. I'll just take the join. You can do it. I mean, I've shown you 1, 2, 3, 7 ways of doing it. I'm just picking up one here. So this tells me all those titles that are desired and are in the listings. If you run this query, that's what it showed me. Now on this, I want to impose the condition that I only want to see computer programmer. Why? Because computer programmer has more than one contacts looking for computer programmer. So what will you do? Logically, group them up as we did before, but this time we need to do it. Group them up. After you group them up, you only want to pick up those groups. Remember you're having, oops. Where the count of that group is greater than 1. So again, I'm refreshing your memories. We had done this in advanced select statements. It's like saying having is to group as where is to from. There is no where here because I'm using the word inner join. If I use comma, it will be where. But that's how you remember it. As from is to where. So when you select something from tables, you give a where condition. Which ones do a filtering? Where? Filtering. Similarly, when you filter, so we say from is to where, as having is to group. So you have grouped them and now you're filtering. Filtering what? Which ones am I interested in? Which groups am I interested in? So the groups you are interested in are those groups where the count of that group is greater than 1. Right? So you're saying, okay, pick up the titles, group them up by titles. So now you are grouped. Now each group has a title. Baker, computer programmer, whatever. In our case, there are only 2. A baker group, a computer programmer group. Now pick up only that group that has a count greater than 1, because the question was more than 1 contacts are in the job listing, which are desired by more than 1 contact and are in the job listing. Right? So this should work. I should only have an answer of computer programmer. There it is. So you can't forget anything, guys. Whatever you've learned from the beginning of the semester is building up. So you can't say in the exam, I can't ask you this. This is anyway advanced select statement. But you've done select statements from day 1. And you've done update, and you've done delete, and you've done alter. So I cannot break up the course and say, oh, I won't ask you select. We are doing select statements. Right? And advanced select statements were done after midterm anyway. So group and having was done then. And minimum, maximum count functions were all done after the midterm. So when you are doing your group assignment, please concentrate and pay attention and do it religiously and seriously. And believe me, you will do well in your final exam. Because it's all about joins and subqueries and advanced select statements and whatever you've learned. Okay? You will do very well in the final exam. So don't take tension about the final if you're working this, and you have 2 weeks. You have so much time. And of course, I've only picked up 1. You can pick up each one of these answers that we've written here from 7A. So you can do the natural join here. You can pick up the natural join. And of course, hopefully, yeah, you can pick it up, add the condition. It will work. You can pick this up and add the condition, and it will work. It will work with everything. So if I pick up this, so I've never done it with an outer join, but there's no big deal in it. It's just a select statement. So what I'll do is, the only thing I have to see is where do I put it? The group by having comes before or after the where. I think it's the sequence is important. I don't see any red squiggly, so that's okay. So the clause is select from, where, group by, having, order by. If you can remember it, and limit at the end, right? So sometimes when we write complicated select statements, we kind of mess up. I may have just put the where condition here, but then it will tell you that something is wrong. You'll see a red squiggly. But if you can keep in your head, select from, where, group by, having, ordered by, and limit. That's the sequence of how it goes. And if there is not a where, on will come here. On and using a kind of depends upon if you're using a join. So if you're using a join, then please add on in between. Okay, on or using in between, which can be done by where also. I could just have done it with where, but I try to use using or on in my joins specifically so that I don't forget my joining condition, right? So keep in mind, don't forget your joining conditions when you're joining table. If I remove them, I'll never have the right result. Definitely not. Because you're saying, oh, join the tables. You're basically saying everybody says hello to everybody. So the joining conditions are a must. And how I remind myself, I don't use where, I use on or using. So that way I don't miss it. If you start using a comma here, for example, in an inner join, I can use a comma, then I don't need on, I can put a where here. And sometimes you may forget. But on kind of reminds you that, oh, you need a joining condition. It's up to you, whatever format you like. I don't mind. I don't mind you using a where here and using a comma here. It's your personal preference. But at least for these ones, I've stuck to the words inner join and I've used on or using. Now I can be a little lazy. I can start using commas, which is less work, and I can start using where, right? Because now I've kind of made my point. Hopefully I've made my point clear. So if you run this, there you are. There's your answer. Right? That takes care of this script. So we'll take a break now and then come back and do one more important script that will help you in your assignment, and then do more scripts, right? But one more that will kind of take care of your assignments completely, so that I know I've taught you everything that is needed in the assignment. I'll put this on Blackboard for you so that you have it. And anytime you want to refer to it, sure, you can do it. So I put it on Blackboard for you. Okay, take a break of 20 minutes, come back, and we'll go ahead and do it. So this is week 11 now.
No, don't go there. Go to the main thing. Go. Okay. Let me know when it shows the break.
Absolutely.
No, you just keep saying how it is. What you say when you're. Oh, yeah, like, see, that's another reason why I think it's because it's just like can't even register for all of them. How about you, Grace?
Mine was fine.
See, there's lots of reasons to think about it.
There's so many things we do. It's really so
And it's like fancy medicine borderline swapping territorial.
yeah. Yeah, I've got like the basis macros on the list. Yeah.
There's one spread and then like 20 things on the side.
Oh, the vote for the there's those, what are those things that people have? Is there little people in the cheap? They're not just like ones.
Like an app. I can tell you research words, that's like
Because there's one guy that I think he's from Australia. He only uses that.
he searched G13 as that thing and
That's my ideal Saturday, right?
G13. The thing I was talking about.
Yeah, this weekend. Really great. Pick up and go. She's going shopping for dresses, for like. Shoot, on board. By the time they after that, Sydney. All that.
See, and here's the other thing. Right here, if you look at the college fee schedule, computer programming, that's the one I did. So it's 3 years, 9 semesters, 6 being school, 3 being work. 1, 2, 3, 4, 5, 6. It doesn't count up to 9, only 6. Meaning co-op is not. It's not going on at all.
That's what
I'm just showing you all this extra proof. Like, you take this stuff to someone and show it to them too.
Where did you take your food? Ever? So just make more churches, but right in year two.
I was talking to Zayed.
Oh, really? That was one people.
No, that's what I was saying. Like, I don't get it. Let's say screw it on.
But even then, you can just do your co-op like later on.
Yeah.
Pretty sure you can just do two
Pretty
co-ops
sure
at
there
once.
is.
You can just get a full-time job and go to school and get co-op, but when you credit school.
Well, no, like they don't let you continue. You would have to drop. And I think there's. I don't think
problem. I think when I go to the doctor's office, I just
Still
go.
rocking the red and white one.
Yeah, I know I had one for the longest.
Every time they ask me, they're like, "One of these days, we're not gonna accept it." I'm like, "Yeah, I've heard that for like 4 years now."
I'll believe it when you actually do it. And when
You
you
need to turn me down. That's what I was gonna say. I'll actually one day it's like, sorry man, it's out of here. Stretch it up.
You got a gun shop? Yeah.
It's not in red and white though. I can't do it. It's like eight feet up.
Yeah.
Oh my god.
That's the most related.
Okay, so let's get back to where we were. And if you can open the file that was given to you with joins and subquery zip, there was a file called clowns there. Please open up that file. So remember the zipped file that you downloaded a couple of weeks back in week 9. You should find clowns _bb there. Open it up and then we'll discuss it. I'm trying to bring a couple of important concepts to your notice using this small one table file, one table database, because I want to show you something that is again new, but you will need it. Oh, okay. So I haven't followed conventions, it seems, which is really odd. So if you want to make that change, please do that. I'm going to pick up my table name and put TBL in front of it. You don't have to if you don't want to, but okay. So now this file, this is a very small file. It has one table, but there is two important concepts that we are going to talk here. One about a self-referential foreign key, a key which is referencing a value in the same table. Therefore, it's called a self-referential foreign key. So we know what foreign keys are. I'll repeat the definition for you. A foreign key is a field whose values are drawn or have to be drawn. It's a rule that you make from a column in another table, right? So it cannot have a value that does not exist in the other table. For example, the jobs that you've been doing, all your contacts had a contact ID. And if the record was present in job desired or job current, that contact had to be in the my contacts table. So you made your contact ID as the foreign key in the other tables, though it was also the primary key, but you made it as foreign keys in that table. And you said that it is going to refer to the contact ID in my contacts table. So that's what a foreign key is. It's a field that draws its value from the values of another field, which is usually a primary key field in the other table. And you impose this rule by adding a constraint for your foreign key. So you say add constraint and you add a foreign key constraint, right? You can give your constraints name and that way you can change them or, modify them afterwards, but that's not what we are learning in this course. But I gave them names in that table to tell you that, yes, you can name your foreign key constraints. It's just a rule. Constraint means a rule. You're constricted to do this. So that's a rule. So I'm not giving them names anymore just because in this one I haven't. It was only a table. Just because now, I'm not going to use them at all. So I can do without that extra line. Okay, what I'm trying to do here is I'm going to create a database and therein store clown information. And I want to show a self-join to you. A table can be joined with itself. Till date, you have joined tables with other tables. You've joined 1, 2 tables, 3 tables. I don't think we've gone more than 3. but there is no restriction. You can join any number of tables and you will have joining conditions for joins. A self join, as the name suggests, is a join with itself. And where and why will I need it? This is a good example of it. Okay. And you will find that you will also have to do this in one of the questions in your assignment. Okay. So again, I'm just doing everything so that you can say, oh, this was not yet covered. So everything till date, when I finish today, you've covered everything that I've asked in the exam. So further, all I'm doing is some extra examples. Okay. Which is always good to see a different viewpoint. Okay, so I've created a database. I've dropped it if it exists. I've created it and use it. Then I've created a table here. But before I kind of talk about the table, I want to show you what the table has. The table has 3 fields in it. And I'll kind of use the whiteboard today to kind of draw the table for you so that you can see what I've done. So this table has 3 fields. It has a clown ID field. That's not too good. Are these permanent markers? Oh, it's highlighters. Flip chart markers. I don't know whether this will work. All highlighters. Oh, they're quite thick. Okay, let's see. So I'm going to draw this table here for you. Right? And because I just kind of need to discuss it. So there are 3 fields in there. There is a clown ID, which is an automatic auto increment integer field. It could have been a small int. It's not required to be an int. It could be unsigned. So, I mean, I can improve the definition. But as I said, the aim is to show you something important. And then there is a boss ID here. Okay, so there are some clowns. And this field will be automatically filled up as you move on, as you insert records into it, right? And then the name of the clown will occur here. And the boss ID, who is the boss of this clown, will occur here. But what you have to understand is that this value that is occurring here has to be one of these valid values, because the boss of the clown is also a clown. Right? So this boss ID, the values that occur in this boss ID have to be drawn from this column. So this is a self-referential foreign key where the values in this field are being drawn from values in another column, which is the primary key of this table, in the same table. But the definition holds. Foreign key says I draw my values from another column. That another column is in another table. Foreign key, that another column is in the same table, self-referential foreign key. Okay, which means I cannot put a value here if that person is not available here. He's not a clown, right? So, and we are kind of making this assumption that the clown's boss is also a clown. That's how it goes, right? So that's the first thing you have to understand. That's what a self-referential key is. 2. To impose this rule that it is a self-referential key, there is nothing different. What am I saying? I'm saying that boss ID is a foreign key. It references from the same table, the name of the table, normal reference statement, and it is referencing the clown ID from the same table, as you would have written any other foreign key constant that you've written till now in your other tables, right? As I said, I didn't give it a name because I'm not going to use it, and so it just saves me one extra line. No big deal. Now, to improve the definition, you could have definitely said that this is unsigned. Assuming that ints, clowns don't have such a big range, but you can make it small int or tiny int if you like. But I like to have unsigned just because ID with the sign doesn't make sense. The clown name varcat20 is good enough. It's just a clown's name. You can go 30 or 40. And the boss ID is again an int because the clown ID is an int. It's drawing its value has to be an int. If you make a small int here, you will have to make it a small int here also. And this rule simply says, oh, the boss ID is referencing the clown ID from the same table. So that's a self-referential foreign key. Also, please keep in mind that the engine that the default storage engine that supports foreign keys is InnoDB. ISAM does not support it. There are a few 8 to 10 storage engines, how the data is stored and manipulated. That's what a storage engine is. And there are 8 to 10 storage engines in MySQL. The two common ones are MyISAM and InnoDB. And the recent versions of WAMP, XAMPP, MySQL all use InnoDB. But again, I don't know what will happen on the server when I put my script on the server. So I've added this statement that the engine is InnoDB. You could have set a set default engine, which I'll do in another example. But here I've just set it for this table. So every storage engine has its own properties, its own restrictions or whatever, right? You can do this, but you cannot do this. You can have a foreign key constraint. ISAM does not support foreign keys. So I have to use InnoDB. 2. Now the next important thing. Because this is a self-referential foreign key, how you insert records in this table is important. For example, when I insert the first record, which is clown ID 1, this clown cannot have a boss ID of 9 because the 9 record has not even been inserted yet in the table. Make sense? So the boss ID of the first record that you input, that you insert, has to be 1. Why? Because no other clown exists as such. The boss ID of 2 can either be 1 or 2 because 1 is already inserted and 2 is now being inserted. The boss ID for 3 can be 1, 2, 3, for 4, 1, 2, 3, 4, and so on and so forth. Or if you were giving these values yourself, you were not doing an auto increment field. If you were giving these values yourself, you have to keep in mind that when a record is inserted, the value that you insert in the boss ID must already exist as a clown ID in that table. It should already be there. The record should already be there. So I have used auto increment, but you could have said, no, it was just an int and I'll input it myself. But all you have to remember is when you insert a record, the value in the boss ID should already exist in the table as a clown ID of another clown. It's like saying, oh, if it doesn't exist, how can he be the boss? That's the rule. So the insertion of records is important. I tried an alter just to show you. You can put the foreign key. I didn't try it. I mean, I want to tell you. You can add the foreign key constraint here itself. But if you want, like you do with primary keys, you can always alter the table afterwards and add it afterwards also. Remember how we said add primary key or add constraint unique win when you did that assignment of cards? You can always alter the table afterwards also. I mean, it is available. You can add a foreign key like you can add a primary key. Okay, but because it was already done. Now look at my table, how I'm inserting my records. I'm not inserting the clown ID because it is auto increment. I don't want to bother with it. The name of the clown is LC and he or she, LC looks like male, I'm not sure. The boss of LC can be LC himself, nobody else, because before this, there is no other record in the table. Pickles is now input, is the second clown. The boss of Pickles can either be 1, because record with 1 ID, 1 clown ID is already there, or it can be 2 because Pickles is the second record being inserted. If you were giving them their own names, C1, C2, C3, then you could have used C1 here, you could have used C1 or C2 here. Okay. Now Snuggles is the third record being added and his boss is LC. Valid because 1 already exists. 1 ID already exists. 1 clown ID already exists. So is for Hobo. Clarabelle's boss is 3 and this is the third record, Snuggles. So that means, yep, that is also okay. If I try to do something like this, though I know 9 will come, but I can't do it. Syntactically, it is not a problem, but logically, when I run it, it will be a problem. It says 9 does not exist. It's like saying, oh, I'm putting in something and that value doesn't exist. Like it was a foreign key from another table. Doesn't matter. It is the same thing. The value in the foreign key field has to exist in the other table. Same is the rule here. It has to exist in the table. So you have to insert the records in a certain order, right? So I'm going to run this for you and show you that the table will be created. Uh-oh. Okay, this is my problem. This is again something to do with my hard disk. Some sectors have gone bad and I can't remove the file and I can't do anything. So I just give it a new name. I'm going to call it clowns2. So I'm going to show you how this data is being inserted. So 2 things to pay attention to. Very important 2 things to pay attention to. 1, still cannot add foreign key constraint. Why? Why is it saying that? Some spelling mistakes. All I did was I changed table to tables clowns information, right? Table clowns info, table clowns info. Oh, no, it's all done. That's strange. Why am I saying? And it's giving me an error in the create table command itself. Okay, so let's look at the foreign key. Boss ID references the table clowns info's clown ID. Strange. What's gone wrong? Run it again. Drop the table if it exists. TBL clowns info. Create the table clowns info. Clown ID, clown name. All I did was I made it unsigned. Oh, if I made that unsigned, I forgot to make this unsigned. There. Because boss ID is referring a value and it is not unsigned and the other one was unsigned. So there has to be some problem, right? Okay, now let's try it again. Hopefully I won't have a problem now. Foreign key is saying, oh, that's an int and you're saying I'll draw it from an unsigned int. It's incomplete definition. Okay, there it is. Okay, here is my table. So if I kind of copy that table on Blackboard, on the whiteboard here, just so that I can refer to it and because I want to talk about it, Snuggles and Mr. Hobo, I'll just kind of and it goes on and on, right? So it's 1, 2, 1, 1 and so on. Okay. 1, 2, 1, 1 and 3. Okay, so that's my kind of table. I haven't completed it. So the table gets created. Now, please go and reverse engineer and create your ERD. Though there is only one table, you'll say, what do you mean? I mean, there is only one table, but I want to show you something in that one table. But there is a foreign key. Keep in mind, there is a 5 objects. Oops, cancel. Back. Maybe 2 tables are checked. Yeah, jobs 2 was also checked. Okay, so 1 table. Next. 1 total objects. Execute. Next. Finish. Look at the table. It is telling you. So now notice something new so that you know. Clown ID is the primary key. Looks like a key is yellow in color. Down clown name is just a regular field is blue because it is not null. Therefore the blue. Boss ID is a normal field but has red colors, which means red means it is a foreign key. And this relationship is showing the one-to-many relationship, which is correct. It says a clown can be the boss of many clowns. So this relationship is correct. So it is showing you a self-referential foreign key with a one-to-many relationship. One clown ID can be the boss of many clowns. Right? That's what it is saying. So the relationship is 1 to many. So infinity sign is for many. So one clown can be the boss of many other clowns. So boss ID can be repeated in the boss ID. So this is a correct ERD, but you've seen something new here, that you have seen a diamond with a red color. Till now you have seen a key with a red color because the key was a primary key and it was also a foreign key. But here it's not a primary key of the table, so there is no key symbol in front of it. But the diamond says it's a normal field, but the color red says it is a foreign. Okay, so now you have, so when you draw ERDs or when you are using it for your assignment or whatever, you should know what they mean. Okay, so the table is ready. Now let's come to, so have you understood the concept of a self-referential key and the necessity of inserting the records in a certain order, right? I'll show you that it won't work. Let's change this to 9, right? Let's change this to 9, no syntax error. And let's run it again. And I'll have an error. It says, I cannot add a child row. A foreign key constraint is violated. I don't know if it says is violated or whatever is something, it will say something is violated. Fails, it fails. What do you mean by fails? It is failing because it says the boss is 9. But in the table, is there somebody 9 yet? The insertions are done sequentially. Is there anybody with clown ID 9 yet? No. So therefore it fails. Right? So it cannot happen. So it can either be 1 or 2. I just made Pickles his own boss. So similarly, if you try to do this, you add Bobo and give him a 12, you will have an error. Why? Because 12 does not exist in the table. And similarly here, if you try to do something like Pickles 9, it will give you an error. So I'll kind of put it here, but I'll put it in comments because it cannot happen. So just so that you don't forget. This cannot happen. It will give you an error. And this has been written here in comments. I've said a self-referencing foreign key is the primary key of the table used in the same table for another purpose. That's what it is. And boss ID in this case. MySQL will enforce the self-referential constant in the InnoDB engine. It doesn't do it in ISAM. But records need to be inserted in a certain order. Because the boss ID needs to exist. The value of the boss ID needs to exist before a clown record is inserted. Make sense? So self-referential key, your first point, and 2 insertions have to be done in a certain order. They have to be done in a certain order. Even if you write different insert statements, you'll say, I'll write differently. I'll write an insert and another insert and another insert. Doesn't matter. All it is saying is, how can a student attend my class if he's not registered in the registrar's office? You know what I mean? He won't be showing up on my blackboard. Same thing. So if the student is registered in the registrar's office and has a student ID, I can use that student ID and he can be in my class. Same rule here. The boss ID is a value of a clown ID. If the clown doesn't exist, how can the boss ID say, oh, my boss is 9 and 9 doesn't even exist in the table? Okay, so the sequence is important. Now, my question to you, don't look at the answer, my question to you, it says get the name of each clown and also get the name of the clown's boss. So the name of the each clown is right here, no problem. But the name of the boss is not here. So if I kind of duplicate this table, the same table, I'm just duplicating it. And then we will kind of see how we can do it and then we will write it. So I'm duplicating this table. I'll call it clown 1, clown 2. Same table, absolutely same table is duplicated. Clown name, boss ID. Same, 1, 2, 3, 4. I think there are 10 of them, therefore I'm writing 10. Then I have Elsie, then I have Pickles, then I have Snuggles, then I have Mr. Hobo, and then I have 1, 2, 1, 1, and I think 3. Clarabelle, I had 3. Just writing one more so that it's kind of makes, we can talk of it a little. Okay, now see what. Now the clown's name is here. So clown's name is Elsie. Who is Elsie's boss? 1. What is the name of this 1? You go to this table, pick up 1 from here and you say Elsie is the name of this. So that becomes the boss name, right? You go to 2. 2's boss is 2, but who is 2? You go to the other table, which is a copy, look up 2 here and you say, oh, Pickles. And you say the boss name is Pickles. Snuggles says my boss is 1. You go to the second table, you look for 1 in that second table. Under which column? Clown ID column, right? Notice you are picking up the value from boss ID here and you are looking it up in the other table in the clown ID column. You say 1 is my boss. You go here, look for 1 under clown ID and you say, oh, Elsie is the boss of Snuggles. Same for Mr. Hobo. Same for Clarabelle. Clarabelle says my boss is 3. So you go and look under the clown ID table for 3 and say Snuggles is the boss of Clarabelle. So if I can join this table with itself such that the boss ID here is equal to the clown ID here, I can tell you the name of the boss, right? So if I join the table with itself, and the condition of joining is the boss ID in this column, in the first table, is equal to the boss ID of the second, then in a sense, I can give you the name of the clown and the name of the boss. So 1 will join with 1, 2 will join with 2. This 1 will again join with this one. So this 1 and 1 will join, this 2 and 2 will join, this 1 will join with this one. This 1 will join with this one. This 3 will join with this one. So when you have a table, you will have something like 1 LC1, 1 LC1, 2 pickles 2, 2 pickles 2. Your third record, pay attention, 3 snuggles 1, 1 LC1. So you can pick up the name of the clown from here, and you can pick up the name of the boss from here. So when a table is joined with itself, it is called a self-join. And I need it. There is no other way I can answer this question. There is no other way. So to write a self-join, all you do is you write it twice. So I'm going to get the clown name from the first table, C1. I'm going to get the clown name again from the second table, C2. I give them different headings. This is the name of the clown. This is the name of the boss. And the two tables I join are the same table. Table clowns information and tables clown information. And I've just gone with the comma here. You've seen enough of inner joins. But I have to give them different alias names. Definitely, because it's the same table. I have to. I can't do without it. So I've called C1 as my first table, C2 as my second table. And what is my joining condition? The boss ID in the first table should be equal to the clown ID in the second table. Make sense? This is a self-join. And from here, I can pick up the clown name from the first table, and I can pick up the clown name from the second table, which will actually be the boss's name. So I've given it a heading, boss name. So that's an example of a self-join. When a table is joined with itself, you have to think of a joining condition. It could be joined on anything, maybe same fields. But for me, the join was the boss ID here is equal to the clown ID here. You could have said the boss ID here is equal to boss ID there, which is not what will help me. So in your assignment, you will have to decide on what field do I need to join. So I needed to join boss ID here is equal to clown ID here. And I wanted to join the same table to itself. Look at it. That's what I've done, right? So it just keeps joining. So when I look at a field, when I look at a record, it's 1 LC1, 1 LC1. 2 pickles 2, 2 pickles 2. 3 snuggles 1, 1 LC1. So that's my third record. And then 4 hobo 1, 1 LC1. 5 Clarabelle 3, 3 snuggles 1. So when they're joined, I have the clown name and I have the clown name again, but that second clown name is actually the boss's, right? Because this LC joins with LC, pickles with pickles, snuggles with LC. So that's the boss name. Hobo with LC, that's the boss name. Clarabelle with snuggles, that's the boss name, right? So when you're joining the two tables, you will have a bigger table. That bigger table will have 6 fields. The first 3 fields are coming from the first table, and the next 3 fields are coming from the next table. So clown ID, clown name, boss ID. Repetition. Clown ID, clown name, boss ID. Okay, so let's write it. So 1 LC1 joins hands with 1 LC1 because I've said boss ID here should be equal to clown ID here. 2 pickles 2 joins hand with 2 pickles 2. Boss ID here is equal to clown ID here. 3 snuggles 1 joins hand with 1 LC1. Mr. Hobo 4. Mr. Hobo joins hands with 1 again, which is 1 LC1. That's 1, right? That's the 1. 5. Clarabelle joins hands with 3. So who's 3 here? 3 snuggles 1. So what do I want? I have the clown name here and I have the boss name here. So the field is called clown name. It is the boss name. So what did I do? I picked up the clown name from the first table. I picked up the clown name from the second table, right? But I called it clown name because that's the name of the clown, and I called it boss name for display purposes because that's the name of the boss. This is a self join. The table is being joined by itself, and the joining condition is that the boss ID of the first table should be equal to the clown ID of the second. So now if I run it, Elsie's boss is Elsie, Pickles' boss is Pickles, Snuggles' boss is Elsie, Mr. Hober's boss is Elsie, Clarabelle's boss is Snuggles, and it will kind of go on, and it gives me the right result. So that's a self-join, a join of a table with itself, but the joining condition you have to decide. It could be different. I mean, it could be anything. For me, the joining condition was the boss ID here is equal to the clown ID. Okay, makes sense? So this is a self-referential foreign key and a self-join. And there are restrictions. You have to use the InnoDB storage engine for sure whenever you use a foreign key. 2, for a self-referential foreign key, the value in that field must already exist in the table when you insert that record. And a self-join is like a join. It's no big deal. It's just a join. Joining this table with itself, which can be done under a condition. But that's a self-join. Okay? So this example was solely for the purpose of showing you a self-referential key and the ERD of that table and showing you a self-join. Okay, so we are done with this example. Now, let's go to another one. So please open up from your list. Please open up. I'll take an easy one. The sports is bigger. Please pick up the beer one, the beer scripts, BB. I've given that to you also in the zipped file. The zipped file can be found on Blackboard. And I'll save it in your folder. And this is week 11. If you're able to complete it, good. If you're not able to complete it, we'll complete it next week. But it's a little different in the sense that I haven't used the same field names and so on. Okay, so the purpose is to create a database, some tables therein, populate them and extract information from the table. So the information that I am saving is beer information. So many of you will be familiar with it. Unfortunately, I'm not. So if there is something or if I don't pronounce it right, it's just that I don't know what it is called. Okay, here. So normal set SQL mode, and notice how I've set the default storage engine to InnoDB right at the beginning. That means all my tables in this database will follow the same storage engine. Though you have an option, you can go with one table InnoDB, with another ISAM, with another a third one, and so on. It's a choice of the programmer. But for all these tables, because I'm going to use foreign keys, I've just said my storage engine is InnoDB. It is the most common storage engine used in MySQL, for your information. Okay. Okay. Now so it's about beers and brewers and everything and so on. It's not only about and prices of cases. So it's kind of, there are many tables. So I've created a database, some tables therein, populate them with data about beers, brewers, price of beer cases, sales data, etc., and then extract information from the tables, right? So I'll kind of complete it because it may come back on me. So there are no comments here. Seems like I was in sleeping mode, which is okay. Or maybe I've taken it from somebody else, but I've followed my conventions. It's the set command so that if need be to put it on a server, I exactly know what my settings are. The drop database command. And again, just to be on the safe side, because I'm having problems with my hard disk. I think there's something going on because I can't, it's creating problems somewhere else also. So you don't have to change the database name. I'm just changing it because I already have one by that name, and it doesn't overwrite it or something. It doesn't drop it for whatever reason. I don't know. Okay, now let's start looking at tables. So the first table I'm looking at is, just to kind of make it clear so that you can see the tables. The first table I'm looking at as is the brewer's table. Right? So who brews the beer? Right? So what does it have? It has the name of the brewer. So please change this. This is, again, I'll call it the brewer name. It's just that using reserved word is something which I keep away from. Okay, varchar 100 for the brewer's name is a good big one. Oh well, you can always go short. You can go 50 even 40. I don't know. So definitely this is coming from somewhere. I've taken this data from somewhere. You can correct me if I'm wrong. I have only looked at the data in this one and I haven't seen any big names. Anyway, so my first table is the table about brewers, information about brewers. This table has an ID. I just called it ID. You could have called it brewer ID, but I just called it ID. Everywhere I've called it ID in each table. It is an int unsigned auto increment primary key. It has one more field called the brewer name, which is varchar 50, and it is a not null field. It is in the first normal form. It is also in the second normal form by default because the primary key is a single field. I may have to pick up an example and show you the normal forms. It's not coming up. I don't see a composite key. Table number 2 is talking about the cases. The table cases again has a int unsigned auto increment field and has a size. So beers are available in cases of 6, 12, and 24. That's what the size is. Okay. Table number 3 is talking about beers, and here the connection starts. It has an ID which is just a primary key. So it's not like the contact ID where we had that problem of one-to-one relationship, right? Now I can avoid it. It has a name, and I'll change this name to beer name. Okay. And it has a brewer ID, which is drawing its value from the other table. So it is kind of telling you that this beer is being brewed by that company. Make sense? So there is a relationship. The foreign key says that the brewer ID is referencing the ID field from the table brewers. So now in this example, I'm not using the same name for the same related fields. I'm avoiding it. Why? Because you've seen enough of same names. Titles, contact IDs, they were all same. Here I'm keeping them different to prove to you that it's not the names that matter. It's the foreign key rule that matters. So you are saying that the brewer ID here is coming from the ID in the brewer's table, which is saying this beer is being brewed by that company. Make sense? So that's the foreign key. Field names are different, but the rule says there is a foreign key. Table number 4. Table number 4 is giving me the prices. What does it have? It has an ID, again a primary key. It has a case ID. The case ID says 1, 2, 3, and so on. And this case ID is actually drawing its value from the case tables. So it will say 1, 2, 3, but that 1, 2, 3 means 6, 12, and 24 coming from the cases table. Notice how the cases table had an ID and had a size. So 1 for 6, 2 for 12, or whatever. But there are IDs there, 1, 2, 3, 4, 5, whatever, and they have case sizes there. Okay. So I don't repeat the case size again. I use the case ID. And this case ID is referencing the ID from the cases table. You'll say, why don't you just write the case again here, 6, 12, 24? Because data is not repeated in tables in a database for data integrity reasons. You'll say copy and paste. Whenever you want to do a change, find and replace. That's not how it works. Programmers don't think like common man, think like programmers. Data should be present at one place so that if changes need to be made, they are done at one place. If required, you can duplicate or replicate your data, but only if required. Otherwise, data integrity is at stake. You change the data at one place, you forget to change it at the other place, and there is a difference, and this means data does not match. So data integrity, to maintain data integrity and its accuracy and its truthfulness and its honesty, that's what integrity means. Data is always kept at a place and is referred in other places by the help of its primary key. Okay, your student information is only at one place in the registrar's office. It's not repeated for me. Whenever I need to find the information, it is picking up the information from wherever it is in the table and showing it to me. Right? That's what it does. But if required, if duplicates are required, then it is done. But as soon as a student withdraws from a program or a course, automatically it goes away from my Blackboard or from Banner. So all this is linked. It's not the same data is being put at 10 places. This student with this student ID with this email address is in this program in this course. No, that information is at one place in a student table. And all other tables that need to talk to it are talking to it via the ID. Okay, so therefore the case ID here is drawing its value from the ID from the cases table. Then comes the beer ID. The beer ID again is a beer name, but I'm not putting a name here. This beer ID is again referencing the ID in the beers table, where the beers table has an ID and a name, an ID and a name, an ID and a name. The name is not repeated. The IDs are being used in this table. And it has a price. Let me know if the price is not correct. I have assumed no beer is more than $99.99. Case of 24, I don't know. I'm just assuming. If it is, you can make it 5 too. But the data I picked up is there is nothing more than that. So that's the price of a particular case of a particular beer. So case ID will tell me, is it 6, 12 or 24? Beer ID will tell me which kind of beer it is, and it is telling me the price of that case of that beer. Okay. And lastly, the last table is a table that is telling me the total sales. So it again has an ID. I'll change this date to sale date, because again, date is a reserved word. You don't have to. MySQL lets you do it, but again, never use reserved words. So this is telling about sales now. On what date, which beer was sold? So what is this beer case ID? It's telling me from the beers, from the above table. Let's look at these two tables together here. It's telling me what was sold here, which case in which beer with what price, how many of them were sold, and then I can always multiply to find the total cost. And in your assignment, you will have to do some sum and max and min functions for sure, right? So it's telling me that I made a sale of which beer. That beer's information is coming from here. Notice how the beer case ID is referencing the ID from this table. So here is saying, oh, I sold a case of 6 Labatt, price was, I don't know, $20. And the quantity is telling me how many, maybe 5 cases. So 5 multiplied by price will be my total sales. Okay. Or on a date, I sold 6 of one, 12 of another, 6 of another, 12 of another. They will have the same sale date. And if I want to find out what were my sales revenue on a particular date, I can pick up the sale date, and all I do is quantity into price, and I'll get my total, and I can sum it up. And you will need to do it in your assignments too. Okay. But this is the first time, because this is my second example, but here all my names are distinct, though they're linked, but they're all distinct. I've called ID as IDs, but I've called them differently here. So before I even start doing it and running it, I'm going to show you the ERD. But here I've inserted some data. Brewers, it only needs a name. So this name I had called brewer name. I'll have to change it here. So Molson, Labatt, Miller, and Muskoka. I have 4 brewers here. I could have put it in different lines. It just had one piece of data. So it's written like that. Into the cases, it only had one field called size. The values are 6, 12, and 24. These are just insert statements. They look small because there is only one value that you are inputting, right? Each record only has a value. Each record only has a value. The third table is a bigger one. In a bigger means it has 2 fields. It has a beer name, because I changed it. It has a beer name and a brewer ID. So it's saying the Canadian beer is being brewed by one. Now we'll say who's one? Molson, right? Export is being brewed by one again, Molson. But I don't copy Molson here. I could have put the name of the brewer here, but I don't, because this is a design principle. Do not duplicate data. Keep the data about a entity at a place in a table. So all information about brewers, though it's only a name here, it could be an address, how many companies, how many places in Canada, and so on, whatever. But all information about brewers is only kept in a table. All information about case sizes is put in a table. All information about beers is put in a table. And it's not repeated in the sense, I don't put the brewer's name here. I just say, oh, 1, 2, 3. Blue is being brewed by Labatt. 50 is also being brewed by Labatt. High Life is being brewed by Miller. So is Light, Cream Ale by Muskoka, and Premium Lager by Muskoka. Pardon me for all my pronunciations if I'm not saying them right? I have no idea. But of course, some are easy, some are just maybe that's not how you say it. So that's my third table. My second last table says, okay, now what are the prices? And I've kind of put three together so that I'm telling you about Canadian. So Canadian, so the three fields were, let's look at the table beer cases again, table beer cases. ID is just ID, I'm not adding it. The case ID tells me the size of the case. The beer ID tells me which beer, and the price tells me the price. So if you look at the table, you don't get much information. 1, 1, 10, 50. But if you kind of read about it, one was case 6. This one is for Canadian, and this 1050 is the price. This 2, again, 2 for what? Case number 2, which was 12. 1 for Canadian, 2050. 3, case number 24. 24 case. 1 is for Canadian and 37.95 cents for Canadian. So I've put all records for Canadian here, the Canadian beer, all records for export together, all records for blue. Seems like 50 High Life and Light are only available in 12 and 24, not available in cases of 6. And Cream Ale and Premium Lager or Lager, I don't know, whatever, is available in all 3 sizes. So these records, if you look at the table, you can make much head or tail out of it. But when you start answering questions, you will have to say, oh, I want to pick up the name from here, the size of the case from here, the price from here, and so on. That's where you will have to kind of join tables. And the last table was about the sales. So on 15th of March 2012, it says I sold 1. So this is coming from this one ID, I think. And I'm not sure what the third was. Quantity. Okay, so sale date, beer case ID, and quantity. So 1 was sold of 1. Now who is this 1? The 1 means this one. This one. Right? This one is what it is talking about. So this one was sold of 1. And similarly of 2, of 3, of 5, of 6, and 7 in it. So if I run this script, oops, if I run this script, unknown name date. Okay, I changed date somewhere to sale date and I forgot to change it here. I changed it to sale date, remember? There. Let's run it again. There, those are my tables. The first 2 tables are not difficult to read. Right? The first 2 tables are not difficult to read. But as soon as I come to the third table, the third table is also okay. This is about the sizes. But 4th and 5th tables are not easy to read at all because they are referring to the other tables, and that reference is through IDs. But notice, here it is called case ID, whereas this case ID is called ID here in the case table. Here it is called beer ID, but it is called ID in the beer table. So now it's kind of, therefore some programmers say, let's give them the same names, then we don't have to bother. The other programmers say, no, it's too confusing. Then it becomes, then I have to qualify every field every time I want to work with it. So it's up to you. Would you like to give them same names if they are related or go this route? It's entirely up to you. But what will help us is this. So once I run it, I can go and create my which of course should have been done again before I did it. And it was called DB Beer 2. I did it. I think _2 is what I went. Uh-oh, something else was also selected. So we'll close this and we'll go back again. I think more than one were selected. I'm just double checking what did I call my database. _2 or _2. Okay, let's do this again. Database, reverse engineer, next, just to be sure that I only have one. I had the clowns ones also. Anything else? I had the jobs too also from previous ones. Okay, so only one now, DB Beer 2. Next, 5 total objects, and next, and finish. Okay, let's kind of put them so that they're easy to read. That's the cases table. It's related to cases. So if you kind of put them a little neatly, they'll start making more sense. If you can kind of place them somehow. So all tables are related. And by the relationship I'm using, and I use this relationship, guys, I go relationship notation connect to columns. So when columns are connected, it tells me ID here is called beer case ID here. Case ID here is called ID here. Beer ID here is called ID here. Brewer ID here is called ID here. So I know that they're all the names, which names means what. So I don't have to give them the same names. So it's your personal preference. If you want to keep the names same, sure, go ahead, like we did it in tables of the job, my contacts. If you want to say, no, I just want to give them different names, you can go ahead. Again, please read the ERD. Primary key is shown as a key symbol and it is in yellow. The diamonds are for normal fields. If it is blue, it says it is a not null field. But if it is red, it says it's a foreign key. Right now, if it is not null and a foreign key, I don't think they can color it both ways. So the red one just says it is a foreign key. So that tells you the beer case ID is a foreign key and it is drawing its value from ID in the table beer cases. Here, nothing. Here, there is a foreign key. Brewer ID is a foreign key and it is drawing its value from the ID field of the brewer's table. Anything else that I see red? Here too. The case ID is drawing its value from the ID in the cases table. Beer ID is drawing its value from beer ID, from the ID in the beer table. So the connect columns tells me which field is connected to what. Colors and symbols, diamonds, keys tell me what is a key, what is a primary key, what is a foreign key, what is not null. And the relationship one to many, many to many, one to one, here they're all one to many, tells me the relationship. Right now, I'm not sure whether they are right or wrong because I have to kind of look at them more because there are 5 tables involved. But we can always say, we can always kind of find out if they're correct. And if not, then please, I've already mentioned this, that the relationships sometimes are not correctly drawn by the ERD of this workbench. So if you cannot rely on it, you can take a printout, but double check and then change it if required. Or use any other program. There are many programs, I'm sure, on the net that help you draw ERD diagrams. Okay, now let's start answering questions. We won't be able to complete it, but let's start at least. Let's look at the first question. So are we clear about the tables? Now let's look at the first question. It says, show all the brewer names and their beers. Their beer means the beers they brew. That's what they mean by their beers in one list, right? Now, what is this list? It just doesn't mean anything in one list. It just means show them. I mean, we have never used this word in one list. So show all the brewer names. Brewer names are coming from the brewer table. We know that, right? And the beer names are coming from the beer table. You know that too. So go back to your ERD. Where is the brewer name coming from? Table brewers. Where is the beer name coming from? Beer table. So these are the 2 tables to be joined. What is joining them? The ID here should be equal to the brewer ID here. Right? So let's write it now. Okay, so let's go ahead. We are going to select, and I'll tell you the field names so that we don't keep dancing. Uh, okay, so the first field was called brewer name. I changed it to brewer name from name. And if you like, you can make it a little neater like this, comma, and the name of the beer was called beer name. If there is any ambiguity, then if they were both names, I had to qualify them. Now there is no ambiguity. And this is the beer name. You can just say beer. Right? The two tables that you're interested in. The two tables that you're interested is in table brewers, I think was the first one. Comma, I'll just use comma now. Just to show you a different way. Oh God, it's still sitting on the table job currents. These are the two tables that I'm interested in. Hopefully, yes, it is called brewers and beers. Now I don't have to qualify anything. Name, brewer name, by default is from brewers. There's no ambiguity at all. It's not present in the other table. If there is ambiguity, then you give them names and so on. But there is no ambiguity here. What is your joining condition? The joining condition that we just saw was that the ID from the brewers, the ID from the brewers table should be equal to the beer ID in the beer table. Again, I don't have to qualify it because there is no ambiguity at all. If you like, you can. You can give them names. Table brewers is called TB, table beers is called B, and you can do it. But field names are not common even. There's no common field names. I cannot use on here now. This is my joining condition. This is my joining condition, guys. With the comma, you cannot use. Let's also just order it. Let's just order it so that you don't forget there is an ordering also. And let's order it. You can order it a certain way. I've said brewer name and beer in that order. Right? So order by. Now you can use this name here if you like, because it's a valid name. The name of the field, comma, inside that by the beer name. Oops. Control. And of course, you can also use 1, 2 if you remember. First field and second field. Not by 1 and 2 because 1 is occurring here. That's the first field and that's the second field. So it will tell me which, and again, you can make it ascending, descending, whatever, right? By default, they are ascending. So it's, I'm trying to show which brewer is brewing which beer. And the brewer name is present in the brewer's table. The beer name is present in the beer table. So you can use the name of the field to order. You can use the position of the field in the select clause. 1 and 2 are the positions of the field in the select clause to order. Or you can also use this alias name, but the alias name has to be a single word. But brewer name is not a single word and beer name is a single word. So I'll kind of let it go, right? You can always do this. Let's see if it works. Should work. I don't know. Uh-oh, no, it doesn't work. ID clause, ID is ambiguous. Oh, there is an ID in the beers table also. Oops. Though I'm not relating it, but there is an ID. Okay, so I'll have to do a table of brewers. Oh, though I'm not using it, but it still says there is one there. Which one do I use? Beer. I'm talking about the ID from the TB table. There. Why that error came up? Because there is an ID in the other table also, in the beer table also. Though I'm not using it, but how does it know which one are you using? You've said join 2 tables. So ID from which table? I don't think there is any ambiguity now. Let's try to run it. Again. Again an error. Unknown column beer ID. What did we call it? Okay, so something is not right. Give me a minute. This has an ID and this has a brewer ID. Oops. Maybe it's better just to give them the same names then, but no, I'm not going and doing that. Next time I'm going to get a printout so that I don't forget, or make a note at least. Okay, let's try it again. Sorry about that. It was called brewer ID. Here, I picked up the wrong name. From the table beers, it's called brewer ID. And here it is called ID. And there was an ID here also. So we had to take care that which ID are we talking about. We're talking about the ID from the table brewers. And I don't have to qualify this because brewer ID is only occurring in one of the tables. Hopefully now it will run. Okay, now there, at last. So it's just, you have to be careful. Okay, so it's telling you, and look at the ordering, please. L, M, and O. So it's L and M, nothing else. By ascending order of brewer name, and then within the brewer name, again by ascending order of the beer. So 50 is smaller than blue for your information. Digits come before capital letters in the Unicode and also in ASCII, but they come after the small letters but before the capital. I don't know why they did it. They didn't put the letters together. So small a to z, 0 to 9, capital A to Z. That's what their sequence is. So therefore 50 is less than blue. So notice Molson has Canadian and export, and they're already in order, C and E. So it is ascending here also, and it is ascending here also, which you can change. You can change it to descending. We'll do it in the other one. That's how you get the brewer's name and the beer name. Join. So I have stopped using the word inner join, and instead of on, I have used where. If you don't like it, don't do it. Do it your way. Use inner join and use on if you can remember it, if that's how you remember it. But if you read somebody's code in the job, in the real life, you should know that it can also be done this way. Okay, now it says all case selections. The names of the beer, the case sizes, and the case prices. So I want to know this beer, what size is it available in, and what price is it. So let's go back here again. So definitely price is coming from here. So we need this table, right? The price is coming from here. The name of the beer is coming from here, table beer, right? What else did we need? Case size, beer, and price. Case size. There is a case ID here, which means it is drawing its ID from here. So we need 3 tables. Because the cases information is in the table cases, the beer information is in table beers, and the price information is in table beer cases. So 3 tables to be joined. So let's join them. So let's do a select. What do they need? The name of the beer. So the beer name, I'll let you know the fields now, okay? So that we don't make a mistake. The beer name was called beer name. You can give it a name. You can just call it beer. First field. The case size is called size. No ambiguity. And again, you can give it a name like case size. And the case price is called price. And you can again give it a name, case price. Sometimes names are just easier to read. And for consistency, I've given them all names. These are the 3 fields I want, right? From which tables? The beer name is coming from the table beers. And there is no rule that whatever you need, you may not pick up a field from a table, but you still need it in join, or vice versa. Okay, so it may happen that you don't pick up any field from a table, but it still needs to be joined for checking a condition. So that doesn't mean, oh, there are 3 fields, I need 3 tables. It could be 2 fields and I still need 3 tables, or there could be 6 fields and I need 2 tables. So there is no relationship between them. Here, by chance, it is. Okay, so this is coming from table beers. The case size is coming from table cases. And the price is coming from table beer cases. It's still on the job settings on the previous one. There. So these are the 3 tables. Again, instead of commas, you can say inner join, inner join, inner join. You can use the word inner join, right? I repeat again, there is no relationship between the number of fields and the number of tables being joined. But you have to join the right tables. No extra tables should be joined. That's redundant code and you will lose marks in the assignment. So if you need a table, join it. If you don't need a table, why should you join it? So that's the first thing you decide. Which tables do I need to join? And then which fields do I need to show? You may be not showing a field from a particular table, but you may still need to join it for whatever I have asked. Okay, so we need to know the case selections. And now the joining conditions. So now come your joining conditions, right? So there are 3 tables, so definitely there will be 2 joining conditions. Okay, so now let's see what is joined. The table beers has an ID. Oh, so we'll have to give them names because an ID is present everywhere. B, C, and BC. Okay, so the ID, the beer's name ID, okay. So give me 1 minute, because I have to think, right? So the beer's ID should be equal to the table beer cases ID, which is BC. There is a beer ID there. We called it beer ID there. That's my first joining condition. How am I joining this table with this table, or this table with this table, or with this table with this table? You can only join tables if they are related. And I'm not yet done. 3 tables are being joined. 1 more joining condition. And my second joining condition is that the ID in the C table should be equal to the case ID in the BC table. I think so. It was called case ID. That's all I did. I kind of put the word beer or case or brewer in front of it. That's my second condition. Here are your joining conditions. So that's an inner join, and here are your joining conditions. So you use where to join conditions when you use comma instead of the word inner join. And if you wanted something else like a normal filtering condition, you can join it and or whatever. So when you use commas, you have to use where. You cannot use on. You can always add, for your information, you can add other filtering. What is filtering? I mean, how are you filtering your records? You can always add filtering condition if required. So now where becomes common, right? Where has the joining conditions also, where has the filtering conditions also. Where price is greater than 20, for example. You know what I mean? So where kind of has everything. Joining conditions, and here is where students kind of forget to put the joining conditions because where always seems to be filtering. So therefore I stick with inner join and on so that I don't forget. You can make your choice. I'm only showing you the other ways of doing it. Add other. Okay, so beer name, the size of the case, and the price of the case. The beer name is coming from the table beers. The size is coming from the table C, and the case's price is coming from this table. But how do I join it? The ID in the beer table should be equal to the beer ID in the BC table, and the ID in the case table should be equal to the case ID in the BC table. Now, I didn't have to qualify this at all because, again, why? Because they are unique. There is no ambiguity, but just by habit, just because I was saying B.ID, I went BC.ID. And let's see. Oh, let's order it also. Let's order it. Order by beer name descending, just for the heck of it. And in there, what is the second one? Case ID. Case size. And we'll keep the case size as ascending. And of course, you can't do anything else. The third field is price. But I mean, the price is, if you want to, then it can, but there will be only one price for each. So it makes no sense. And let's add that order by here. So I can say order by. And just because we've done it by names there, we will do it by positions here. So the beer name comes first, but by descending order. Okay. The case size comes second, and it's ascending. You don't have to say ascending. Ascending is the default also. So you can do it without that. But you have to say descending. Oh, what doesn't it like? Oh, this still doesn't like something. Oh, the word by is missing. There we go. Okay, so you could have said beer name descending, size ascending, and it will work perfectly fine. But since I have already done it here, I just wanted to show you that 1 and 2 are the positions. So you can make a note. 1 and 2 are positions of the fields in the select clause, guys. It has nothing to do with the table. Right? So you can make this, I'll just put it here so that you can see it. Ascending is default, so you don't have to say it. You can avoid it. 1 and 2 are positions of the fields in the select clause, this clause. So if we wanted to do opposite, you wanted to show cases and beers inside it, we would have just said 2, 1. Okay, you can change it and see. Okay, let's see if we have the answer. So we'll run both of them. We'll save it. We'll run. We only have 2. And I'll let you go after this. So this is the result of what we just did. The beer in descending order, P, L, H, and so on in descending order. And within them, the case size in ascending order. 6, 12, 24, 12 and 24. Light was only available in 2. 12, 24 for high life. 6, 12, 24, 6, 12, 24, 6, 12, 24, 6, 12, and so. Remember, 2 were not, 3 I think were not available in 6. But 6, 12, 24, 12, 24, 12, 24, 6, 12, 24 is ascending order. And the beer name is in descending order. You can just change it. You can do it this way. You say, oh, I want to do it this way. All 6s together, and in there, the name of the beers. So all 24s will come together. Here. All 24s are first shown, then all 12s are shown, then all 6s are shown in descending order. And in there, 50, blue, Canadian, whatever is shown in ascending order. So you can do whatever you like. I mean, I'm just showing you that 2 and 1 makes sense. So we'll just change the question. Order by case size ascending and beer name ascending inside it. So it depends on how you want to show it, right? So I've just changed the order just so that you don't think, oh, it's always has to be 1, 2. It could be anything. 1, 2 is just saying the first field, and then the second is the minor field. 2, 1 is saying 2 is my major field, and then 1 is my minor field. And if you just want to kind of maybe reverse, you want to show the case size first, just reverse it here. Just reverse it here, because it makes it more clean to read. Here. Now the case will show first, and then the beer will show. I mean, here it was kind of difficult to read, but there is no connection between how you're showing your fields and how you're ordering them. Oh, but now I'll have to say 1, 2 again. So I won't do it, because my main aim was to show you that I can say 2, 1 also. Don't think it's always 1, 2. So 2, 1 says, this is my major field on which first the ordering will be done. So 12, 12 and 6, 24 and 6. And then inside that, beer will be done again in ascending order, because this was ascending. Right? So I've kind of changed here. Order by case is, oops, okay, sorry. This is descending now, and this is ascending now. We've gone opposite, right? Sorry about that. Just showing you that there is no rule saying 1, 2 or whatever. Here, I'll put this on Blackboard so that you don't have to change the comments. But that's what I've done. So 24, 12, 6 is descending, going down. And beer name is ascending. 50, blue, Canadian, cream ale, export, high life, light is ascending. Okay, and I'll put this back on Blackboard for you. It's not yet complete, but the time is done. We'll do 3 and 4 next week. And I'll bring more. You have the sports one already, and I have enough. But I want to do normalization also, and I'll see if it's not in sports, then I'll pick up another example. Okay, let me put this on Blackboard for you under your week 11 then. So you are Thursday section. So whatever we've done, you already have the clown one, okay? I didn't make many changes in clown. I don't think I did anything. Oh, I made it unsigned. So I'll add the clown ones and I'll add this incomplete. This is incomplete, guys. Keep in mind. Week 11 clowns and week 11 beer scripts Thursday. There you go. Everything we've done today is now on Blackboard under your Thursday section. Okay. Okay. Thanks for your extra 5 minutes. So we'll come back next week and do this again. Complete this. Oh.
Honestly, I thought the same thing. I was like, this can do this.
Group assignment, you want to draw out our own ARD, right? Like make our own ARD.
You can, or you can take a printout of this and clean it up
Okay.
so that it is correct.
Right.
Right? Yeah.
Now there is they might have already done the test. Katie has it. Oh.